Can you hear me now? Yes. All right. Hold on. Let me do this. All right. You can hear me now, right? All right. Whew. So, where were we? Good afternoon, everyone. Andres, Sujay, Arasto, Monique. Oh, good to see you. It's been a long time, Sujay. It's been a while too. Arasto, you're here again. Oh my God, you're amazing, man. What? Where are you? Where are you right now? Are you in India? Are you in Japan? Where were you? Have you moved to Japan already? Or what's the state? What is the time? Whatever you're calling from. Okay. Okay. Let me prepare a couple things here and there. Let me fire up some Visual Studio. In Iran now, 10:30. Man, you're a warrior. You're a computational warrior. That is amazing. I'm not sure if I would stay up until 10 a.m., 10 p.m. on a Saturday to watch this kind of stuff. Thank you, sir. I appreciate it. Where are we? Okay. So, let me set up myself a little bit. Okay. Thank you. You're very kind. Okay, so what are we doing this afternoon? All right. So for those of you who just dialed in, my name is Jose Luis. That's the first thing. It's right there somewhere in the corner, and we do these live streams where I record videos on different aspects of computational design. Most of them are technical tutorials. Some of them are longer videos, like an hour and a half, where I break down some complex algorithm. Some of them are shorter. They just focus on a particular technique. And right now, I'm in the middle of recording videos for a computational design playlist. Let me show that actually. Why not? So let me do this. I'm actually in the middle of recording videos for a new playlist that we are making, which is called Learning C#, an introduction to computer programming for designers. So if you're new, if you just showed up on the live stream and you don't know what's going on, I'm basically recording this playlist where I'm teaching visitors how to learn how to code, and I'm using C# as the programming language. And the examples and some of the things that I'm focusing on are specifically more geared to designers. Okay, we've already published a bunch of videos that go all the way from the beginning: how to install C# Studio, Visual Studio, how to run C# code, create small console applications, and then basic things such as variables, arithmetic, and that kind of stuff. And this morning, we recorded, what did we do this morning? We did expressions, Boolean, arithmetic, we did conditional statements, and we started with iteration. So we did while loops this morning. So what I'm going to do is I'm going to continue this afternoon, and I'm going to record more of these videos for the playlist. Those are going to be, I'm going to go into for loops, which is probably one of the most fundamental or important structures in computer programming. I'm going to do that, and I'm going to continue with nested loops, so how to combine this power together. And I will probably want to wrap up today by just doing like a bunch of exercises. So like numerical series, Ascii Art, we can do a lot of stuff with that. I'm not sure if I will have to get time to get into data structures. I would love to, but I'm going to be tight on time probably. So I don't know if I will get there. And then I use these live streams to hang out with all of you who are watching them live, and actually, like, very often I do Q&A while I'm recording, and this helps me actually sometimes craft the videos differently so that I understand where people are struggling and I can focus on that on the video. I can also do questions while this is, I don't know, it's a really cool model. I really like in this idea of recording videos and tutorials while we have people on the chat giving me feedback. I think it's great. But then after the videos, what we do is we take the recording. Am I recording? I am recording. Yes, we take the recording and then we just cut it, we just chop it, and then we publish these videos that you can see here on the playlist right now. So these videos actually were recorded live in some previous live stream, that like this one that you're watching right now, and then we edited them, we cut them, and we shrunk them, and now we publish them as like digestible bits that people can follow one after the other. So whatever we're recording today will eventually show up on the channel as standalone tiny videos, and they will be added here to the playlist at some point in the future. I'm very lucky to have a team of people working with me on this. For example, Erasto, who you can see in the chat right now, has been helping me a lot cut these videos. Rami, who was also this morning in the stream, he's been helping me a lot. We actually have a computational workflow to do that, which I could probably make a video at some point about this, right? Anyway, so what I'm going to do today is, this is going to be a 2-hour, give or take, stream. What I'm going to do is I'm going to go over for loops, nested loops, and I'm going to do a bunch of exercises. So like here, I'm going to say, okay, let's practice what we've learned so far. And I'm going to do a bunch of examples of that. And then I'll probably open it up to Q&A and some social by the end of this 2-hour period, okay? So you're welcome to follow me with your own Visual Studio. If you don't have Visual Studio, you can go to the playlist and there's a video that explains how to install that. And if you want to catch up with the content for future, and if you never coded at all and you want to catch up with the content of future videos, just go to the playlist and start going one after the other. I'm not even sure how long all these videos together are. I wonder if there's somewhere on YouTube that we can calculate that. Is there a way in YouTube to know what is the total length of the videos on a playlist? Total length videos in the playlist. YouTube playlist length. You can enter a playlist link. Oh, what? Okay, so let's do that. Playlist and the ID, get the length. Number of videos 25, average 2 hours and 56 minutes. Okay, so 3 hours more or less. Okay. At 125, at 1.5, I watch tutorial videos at 1.5 actually. Yeah. That's pretty awesome. Okay. So the playlist is about 3 hours right now. I wonder, do I care about the length of the list? I mean, I care about covering all the important stuff. I'm not sure. Seriously. I'm not sure I care about, I don't know. Okay, whatever. It doesn't really matter to me. I care about making quality videos and make sure that the message gets across. So yeah. Okay, so what we're doing today is going to be for loops, etc. Yeah. And before I get into that, I have my coffee. And I am going to just start, right? Why not? Any questions? Any questions? Anyone in the chat? Anything that I might be missing, forgetting? Well, if you just landed here as well, we have a Discord channel where we keep offline conversations. And I'm going to copy the link here on the chat in case you want to join us. Okay. So, for loops. Okay, so let me start a new project. It's going to be here, and it's going to be on the desktop. Just going to put it on the desktop. Where is my desktop? Here. And it's going to be something like 24 for loops. For loops. There you go. And okay, and for this one, I'm going to, now that I remember, I am going to just let pop this window here, and how am I going to explain for loops? I probably want to make a link with the previous video where I discussed the idea of initializing a variable, updating that variable, and a check. So I probably will have, maybe I have this example, and maybe I have this example and I explain how I want to build on top of that. So maybe I'm just going to copy it here, and I'm going to remove everything, all the fluff, and I'm just going to comment it out like that, and then I can start writing here. And then I can start like, so that I take the same pieces. So maybe that's a good way, yeah. Okay, so let's start, let's do it that way. And how did I finish the previous video? Okay. So in the previous video, we learned how to create iteration and repetition using this new structure that we have learned called the while loop. Okay, which is what you can see right now here on top of me. However, I was explaining in the previous video how, in order to make this work, we basically always follow a very similar pattern, which is we initialize a variable. Okay, so something that, for example, starts at the value of 0. Then we use that variable to check the condition of whether we want to the while loop to keep iterating or not. And then we change within the iteration loop, we change the value of that variable so that by increasing it, decreasing it, or changing at whatever pace, at some point, this condition doesn't meet anymore, and then the while loop stops and it continues executing. All right. The idea is that this pattern was so common, became so prevalent and so important when writing programs, that actually the people who designed computer programming languages, decided to create a new structure that replicated this pattern, but it made it more concise and more explicit, more like a package with this whole pattern. And that's what very soon became for loops in computer programming. So we're going to learn a new structure. It's called for loops, and it's by far, far, far one of the most popular, if not the most popular, way of doing iteration and creating repetition in most computer programming languages that I know of, including C#. All right, and let's take a look at how that works. So I have copy-pasted the code that runs this tiny while loop that we're using to print all numbers from 0 to 9 to the console. Okay, so this is the basic, and again, we have here the initialization, the update, the check, and the update. All right, so what I'm going to do is I'm going to comment this out, so I'm going to deactivate it from my program, and what I'm going to do is I'm going to write the same functionality, so printing all the numbers one at a time to the console, but with this other structure, the for loop. And I'm doing this because I want you to keep in mind the mirroring, the symmetry behind this pattern of initialization, check, and update that I'm talking about. The way for loops work are very similar to the structure of the structure of the structure is very similar. The syntax of the structure, that's what I meant to say, is very similar to other structures. So we always start with a word, with a keyword, like for example the word for in this case. We open and close parentheses, and we open and close curly brackets. All right, and inside of this parenthesis, inside of the curly brackets is going to be whatever code we want to run, but inside the parenthesis, not only are we going to have just the check to see if the for loop should continue executing, but we're going to pack those three elements that we need for a correct iteration loop to work. Those being the initialization, the check, and the update. So what did we do in our previous while loop? What we did was, first of all, we initialized a variable that we meant to use in the for loop to control the for loop, right? So here we're going to do the same. The first thing, the inside of this parenthesis, we're going to have these three elements, and the first one is going to be the initialization. So here, for example, I can declare my variable, for example, int I equals 0, for example, and whatever I put inside of this first statement is going to be whatever I initialize for my for loop. Then here inside of the second part, I'm going to write the check or the expression that needs to be true for the for loop to continue executing, just like I had it in my while loop before. So that's going to be I is less than 10, right? And then on my the third part of this parenthesis, what I'm going to write is what kind of update condition do I want to execute every time the for loop finishes one of its cycles. So in this case, what I want is to take that variable of I and then increase it by 1 unit. So I'm going to type here I++. All right? And then inside of the block, what I'm going to do is I'm going to run the code that I want to run repeatedly over my for loop. All right? If I run this code right now, we can see that I get a very similar, actually an identical result to what I was getting before with the while loop. I get all the numbers plotted from 0 to 9, one after the other in my console. Okay? However, the idea here is that I have gotten the exact same result, but in a way, this, instead of taking, I don't know, 4, 7, I don't know how many lines of code this is basically one line of code that defines how the for loop works, and another line of code which is the code that happens in between, inside of the block. Remember, I don't have to have it anymore inside of my for loop because it's already part of the declaration of the for loop. Okay, I'm going to continue now describing more of how this works because it's really, really important. So what am I going to do? I'm going to what am I going to do? I'm going to explain what the life of one of these cycles. All right, I'm going to explain that. I'm going to make some changes so that I can see, for example, how the for loop may or may not work in different ways. I'm going to explain that typically I is a very common name for the variable in for loops. And I'm going to explain why as well. Okay. Before we go into any more examples, I want to really make sure that we understand what's going on here, because it's my experience that for loops, sometimes when we're beginning, it takes a little bit of time to wrap our hands around how they work. So I'm going to remove all this fluff from here, and I'm going to concentrate on what we have. And I want to make sure that we understand how a for loop works. Again, the for loop has three main parts, and when the computer reaches the for loop for the first time, what it does is, first of all, it runs this piece of code, the initialization. It creates a new variable called I, which is only going to have, it's going to have a life expectancy only of the life of the for loop. Right after we finish executing the for loop, this variable I is going to cease to exist. It's not going to exist anymore. And that is because of the rules of variable scoping, which I haven't explained yet, but I will explain very soon in another video. And then when this gets executed, all right, we have a new variable called I. It has the value of 0. Then the first check kicks in. And the first check is this variable I, is this less than 10? If all of this is true, then the for loop is going to run one cycle. All right. So what happens is that because this is true, we run the first cycle here. We print the value of 0 to the console, and then after we execute this line, this block, then this update triggers in. It kicks in, and then the value of I gets increased by 1 unit. At that point, we start the new cycle of the for loop again. The new cycle starts by checking if I is less than 10. Remember that I now has the value of 1. It is less than 10, so the block of code inside of the for loop executes. At this point, we print to the console the value of 1, and then the update condition triggers after we execute this. So now, by the end of the for loop, the value of I has the value of 2. We start over again. We check number 2 is less than 10, so we print number 2 to the console, and then I becomes 3. 3 is less than 10, we print 3, and then becomes 4. 4, 4, 5. 5, 5, 6, 6, 6, 7, 7, 7, 8, 8, 8, 9. 9 is less than 10, we print 9 to the console, and then I gets the value of 10. And then a new cycle of the for loop kicks in. 10 at this point is not less than 10 anymore. It is equal to 10, but it's not less than 10. That's why at this point the for loop breaks. We do not get to print the value of 10 to the console. That's why on this series the numbers are ending at 9. And then the program continues with whatever code was running afterwards. And that's when we hit the console read key, which stops the console program. It waits for a key, and then we can shut down and the program is done. All right. This is the main way for loops work. And this probably here, the printing the first 10 numbers is probably the most canonical way of writing a for loop. But there are many, many different ways of writing for loops, and there are many different options. So for example, let's say that I wanted to, instead of writing the first 10 numbers, I wanted to write them at intervals of 2. So what I can do is I can say, instead of increasing the value of I by 10, by 1 unit, I'm going to increase it by 2 units. And then when I run this code, you can see that I print 0, 2, 4, 6, 8, but I also don't print 10, because when the I gets the value of 10, then 10 is not less than 10, so it doesn't, the code in the block doesn't kick in. Let's say that I wanted to print more numbers. I can increase the value of the limit to, for example, the value of 100. And if I do that, then my program is going to print out a huge list of numbers all the way up to 98 at intervals of 2. Okay? Now, I can also start at any random number. So for example, I can start with the value of 90, all right? And at intervals of 2, I will basically print a series from 9, 92, 94, 96, and 98. I can also, for example, instead of increasing in value, I can also decrease in value. I can count backwards. So for example, instead of going up, I could go down in 1 unit. But guess what's going to happen with this for loop if I do this? If I run this code, then my for loop is going to start printing numbers in decreasing, in descending order, and it's going to execute forever because the way I have designed my for loop is ill-defined. And because the numbers are decreasing, I is never going to be greater than 100. So my program is right now stuck in an infinite for loop, just like I did with my while loop. So we have to be careful with those things, and I actually have to force close this program right now. Okay? There's no reason why I should be an integer either. So I could define a float here and say, for example, or I could define a double, and double A is going to be equal to 3.25. Is going to be A is going to be less. Let me just do I. It doesn't matter. I is less than 100, and I every time is going to increase by a value of 1.5. So I'm going to multiply it by itself by 1.5 so that it grows exponentially. All right? So that generates a value that grows very, very fast all the way until it hits 23.20, 83.29, something. Okay? All right. What was I going to say now? What do I want to say now? Oh, I want to say why I is a typical name for is a typical name for the variable that we define with a for loop. Okay. So as you can see, there's a lot of flexibility about what I can do with a for loop. Again, so long as I keep this pattern of initializing something, checking the value of that something for the continuity of the for loop, and then making sure that I update that something so that at some point it hits that limit and I don't get trapped on an infinite loop, then I will be fine. All right? Something I wanted to explain, and this goes back to my initial for loop, was that very typically you can name, for example, the variable that you declare in a for loop, you can name it whatever you want, depending on what kind of for loop you are creating. But typically, you will see, like, I don't know, 95% of the times, you will see this variable being called I, okay? And this is typically because I stands for index number, because for loops not only are super useful for creating repetition, but they're also incredibly useful for creating, for manipulating, and for accessing arrays. And as we will see in future videos, arrays, the way you access the data inside of a list of elements is by the number of the position of that element within the list. So having a structure that gives you, that iterates over numbers 0 to whatever the length of the list is at 1 intervals is very useful to be able to point to those items on the list. All right? And also something that I have not mentioned yet very clearly is the fact that we're doing this to print the number to the console. But very honestly, I wouldn't even need to use the variable I in my for loop. It's not strictly necessary. So I can use the variable I just as a way of maintaining and making sure that this thing executes, for example, 5 times, you know, and then, but I don't really need to use that variable within my for loop. If I just want to print my name 5 times, then I can just create a loop with a value that goes from 0 to 5 at intervals of 1, and then I know that that's going to be like a super simple way of repeating the same action 5 times. It's only if I want variability, if I want things to change while I'm executing this for loop, that I may want to use that value or a combination of that value within my for loop. Okay? So I think this is as much as I want to get within simple for loops at this point. For loops are one of the most powerful basic structures in computer programming. They take a little bit of time to get used to. So what I'm going to do is I'm going to record some more videos about other topics related to repetition. But then at the end of this section, I will probably record another video where I'm going to do some exercises to practice significantly creating sequence of numbers or creating even Ascii art using for loops. And I really recommend that you follow those exercises because they will make you stronger and they will help you to practice and have a wider, more ample view of how for loops can be used for a lot of stuff. They're one of the most powerful structures. So follow me on the next video, and let's get our hands dirty very soon. Alrighty. Ooh, it's getting hot here in Boston. And I close my window because there's a lot of noise. My neighbors are being really noisy right now. Okay, so of a for loop is initialization. Well, I'm going to keep this here as I. I'm just modifying the file so that when it goes to initialization, continuity check, and then update. All right. So how did that go? How familiar or not were you with for loops? Had you ever written one? Was this helpful to understand them a little better? Just let me know on the chat. Okay, so what am I going to talk about next? Okay, so what am I going to do? Okay. All right, it's easy, huh? So maybe I need to crank it up a little bit to keep you guys All right. So let's get busy. So what I'm going to do? I'm going to do nested loops. All right. So I'm going to create a new project. And this is going to be what? 25 nested loops. Print a matrix of numbers. Okay. Can you hear my neighbors? They're very loud right now. I live in like a very small, like a neighborhood that is like is a dead end, and like everybody's like very. It's like a very small neighborhood kind of feeling. And we have an adorable Portuguese neighbor who's like, she loves hanging out and talking to everyone. It's very funny. It reminds me of Europe when I grew up. Um, okay, so where was I? Nested for loops. How am I going to do that? I want to explain that regular for loops are great, but they're very like linear, very one-dimensional. So, and that we can. Oh, wait. Where is this? And that. Uh-huh. No, you can't hear them? Well, then you're missing the fun. I'm sorry. Okay, so I'm going to. Yes, all right. Okay, here. Okay, I'm going to start here. Mm-hmm. Mm-hmm. Okay. All right, so we just learned how to do repetition with while loops and with for loops. So let's play a little game. Let's play mixing everything together and cranking it up. Okay, so let me show you an example. With the for loop that we created before, a for loop that just prints a simple sequence of numbers from 0 to 9 to the console, we can print 10 numbers from 0 to 9 to the console on a row, for example. Okay, and the idea is that we're doing a row of numbers because I'm using here write line, which basically creates a new line character after it prints to the console. It prints to the console. If I were to change this to just simple write, what I would do is instead of writing a character and then going to a new line, then I would basically keep all the characters on the same line. I don't add this new line character. I don't jump to a new line after I finish printing. Okay, and if I wanted to make it even a little nicer, I could add a white space to this. I could add a white space to this writing inline, or I could just say, well, instead of that, what I'm going to do is I'm going to write, and then I'm also going to simple write. I'm going to simple write a white line character after each one of these sequences. All right, and then I have created a sequence of numbers that is linear. It's like a row. It's like a row of numbers. All right, but this is great. It's fun, but this is a little bit of the problem with simple for loops. They're very linear. They're only one-dimensional in a way. So with this technique, I can only write to the console either a column or a row of numbers. But what if what I wanted was to print a matrix of numbers? I wanted to have both rows and columns, almost as if this was an Excel spreadsheet. What if I wanted to have the two dimensions? What if I wanted to print a block of these numbers? Would I have to do this? Would I have to copy and paste this? If I want like 17 rows, would I have to copy and paste this 17 times? Well, right now it doesn't work because I haven't added a white line character. So what about, so I could say, well, after you have finished printing this, can you just write a new empty line? Okay. And then if I copy and paste this like 3 times or 4 times, and I can execute this, well, you can see how I'm printing this matrix of numbers. But you probably see where I'm going with this. just like I don't want to be printing one line of code for each number that I want to print, I don't want to have to be copy pasting things to create repetition, because this, basically, what I have created here, these 4 elements, are basically this element repeated 4 times. Okay? So the idea is that I can create repetition over repetition. So if I want to do this, what I can do is I can just say, why don't I just take this block of code that prints a line of numbers like that? Why do I not wrap all of this inside a for loop that repeats however many times, right? How about I take what I have here and I say, well, this, I'm going to wrap it inside of another for loop that I'm going to open and close here. I'm going to bring all this code inside of the for loop. And now let me create some repetition here. So for example, let me create a variable called rows and row. I'm going to create a row, and that's going to be equal to, for example, it's going to start at 0. Then row is going to be less than, for example, 5. And then row is going to increase linearly by 1 unit, which means that what I'm going to do is I'm going to create an iteration that is going to iterate 5 times and is going to repeat this block of code 5 times. Okay? And if I do this, what you can see is that I have been able to repeat the numbers 5 times over this in the console. Okay, so the idea is that what I just created is nested for loops. Is a for loop that executes inside of another for loop that makes it execute X amount of times, and the result of that is a sort of multiplication effect of this result. So if I was printing 10 numbers to the console, and I asked the computer to repeat the operation of printing 10 numbers to the console 5 times, how many numbers do I end up printing to the console? 10 numbers times repeated 5 times is 50 numbers, right? It's the same as if I told you, can you do jumping 10 times? Can you do that 5 times? So how many times would you end up jumping at the end? You end up jumping 50 times. Is that correct? Right? So this is just a way of combining the effect of 2 for loops and making something that repeats, actually repeating that in itself however many times. And actually, I can do this infinitely. I can nest infinite loops in top of other loops to create this multiplication effect. It's just that, for example, in a 2D screen, very rarely do you need to have more than 2 nested loops, one inside of the other, because it's a 2-dimensional screen. If you were working in 3D, in a 3D modeling environment, then maybe sometimes a three nested for loops, one inside of the other, would make sense because you want to address this 3-dimensionality. All right? And if you want even a bit more of fine control over this, I could declare 2 variables and say maximum number of rows. That's going to be, I don't know, let's say 7. Okay? And then int is going to be maximum number of columns. And that's going to be, for example, 20. All right? And then what I'm going to do is I'm going to say, well, instead of hard coding how many rows do I have, this is going to be max rows. And instead of hard coding how many columns I have, it's going to be max columns. And now I have a program that generates 20 numbers, so 20 columns, and repeats that 7 times. Okay? How cool is that? And if I were to do like in the previous video where I took input from the user in the console and I asked like, how many rows do you want? How many columns do you want? Then I could take this from the user, plug them into the for loops, and then get this 2-dimensional matrix controlled by the user. Another cool thing that we can do is, for example, let's say that I were to rename, let's say that I was to rename row. It's very typical to, when naming nested for loops, it's very typical to name the first level for loop, to name it with the variable I. It's also very typical to name the second degree, the second level, or the immediate parent, to name that variable j, and then however many loops, k, I, j, k, I don't know what's coming next, but like keep that order of lettering afterwards, all right? So something that I could do is, instead of just printing I, for example, that gives me the same number over and over again, what I could do is I could just print, for example, the result of multiplying I times j, and then that will give me this other structure, which just has, like, you see the first row are all zeros because j is always 0. The second one is the normal one, and then this is multiplied by 2, by 3, by 4, by 5. So it's almost like the multiplication tables, one after the other, right? Which I find also pretty cool. So for loops and nesting them together in repeated structures is a very powerful technique, because all of a sudden you get to end with very simple 3 lines of code. I get to generate a lot of content in the screen, and I can control it in a very fine-tuned way, like for example with these external parameters. So nested repetitions are again like a super powerful structure, and I welcome you, I invite you to go to stick around to this series of videos and to go to the last video on this section where we talk about flow control, because I will be doing a lot of exercises of numerical series, so printing a lot of numbers in different ways to the console, and I will be doing a lot of exercises on nested for loops where I will be printing a bunch of numbers, letters, and even some cool Ascii art on the screen, okay? And in order to do that, I will be combining a lot of the techniques that we have learned before. I will be combining nested for loops, I will be combining conditional statements, I will be combining arithmetic. So I think it's going to be really good practice for you. Okay, so check it out. It's going to be somewhere by the end of this section dedicated to flow control. All right. Okay. Monique, is this now good? Is it becoming a challenge or not? Or is it still a piece of cake? Nested loops. All right. And let's do. All right, so let's. What else do I have? Let me do a small video on do while loops. Do I want to do that? I mean, who uses that anymore, really? Still not? All right. Okay, so I guess we're going to have to do some Ascii art. All right. What happened to the weekly challenge? Oh, you're right, Arasto. Weekly challenge. What could we do for the weekly challenge this week? All right. If you guys want more homework, I can give you more homework. I'm always up for it. You know. Let's see. Let me think about it, and if something pops up, then we can take a look at that. So, Ascii Art Challenge. Huh. All right. Okay, that could be. I like that. So who can? All right. Well, let's do that. Let's do an Ascii Art Challenge. Yes. And maybe like submissions to that, we can just share them as part of the videos, or I could make like a small video about like, oh, this is what people from the community made, blah blah blah. That's I like that idea. Okay. All right. So where were we? We're going to do exercise number exercise number 3, because this is going to be sequences of numbers, numerical sequences. This is going to be E3 numerical sequences. No, and I don't want repos. I want desktop. Yes. Should I write them as I go, or should I just write a bunch and start describing them? I could probably, I'm just gonna write them live, because otherwise it's going to be very boring. But let me actually, before we do that, let me write myself here a list of possible candidates for let me a list of candidates. So for example, first 10 numbers, first 10 negative numbers, first 10 square numbers, first 10 even, odd numbers, the multiplication table of number x. Multiplication table of number x, yes. What else? Something with a float. A for loop with a float. What can that be? Oh, a Fibonacci sequence. A Fibonacci sequence. That's interesting. What else? I'm going to leave the Fibonacci sequence for later. Something that multiplies floats. So for example, what can that be? Increasingly small number multiplied by 0.5, for example. What else about numbers? Prime numbers. Can we do prime numbers? How can we do prime numbers? Prime numbers, we can... That's an interesting one, but that would be more for nested loops. Prime numbers. Interesting. How can we do that? So Mm-hmm. Huh. Actually, I'm not sure about how to print the first 10 prime numbers. That would be I think that's an interesting first 10 prime numbers, but that should be an interesting one because it's also we can do that with a nested for loop in a fairly elegant way. Is that correct? Using the modulo, I think we can, right? I think we might do that. What about a string? And the abecedary. Can we do the abecedary? The alphabet. The alphabet. And we can do that by casting. We can do that by casting a char into an ASCII. Does that work? So if I char z equals char 95. Console right line C and then console read key. And what do I get here? It does work. What is Ascii table? I forget what is the value of lowercase a. 97 exactly. 97. So that should be a. There you go. So we can print the abecedary. That is cool. The alphabet. Sorry, I keep saying it in Spanish actually. Ascii table. All right, so that could be cool. What else can we? Can you guys think of examples of numerical series that we could use for loops to print on? We got the alphabet. We got the first bunch of numbers. Something that I could use a first 10 even or odd numbers. And I can do that with a programmatic for loop or using the Modulo Operator. And alphabet, the Fibonacci sequence. Is there anything simpler than the Fibonacci sequence that I can use? I can use I can use a for loop to calculate the addition of the first 10 numbers. That I like that. The addition of the first 10 numbers. A geometric series. What do you mean by that, Monique? What is geometric series? Alphabet, one line, adding then to a string and each line. I see. With a constant ratio between successive turns. Yes, we're going to do that. Okay, so we're going to do that. We're going to do one of those, like a decreasing series, like a number that gets smaller and smaller and smaller, but then it never really. Yep, we're going to do one of those. Yes. Beware. Okay. Okay, so I think we can probably start now. I think we have a bunch of examples that we can do. Okay. All right. Oh, I haven't explained how to break from a for loop. Huh. I want to explain that. So I'm going to record a video of that actually. Nested loops. Oh, I want to do that. Breaking from a loop. And what example could I? Okay. All right. Let me start a new Visual Studio instance. And this is going to be, what is it? What was it going to be? 26 loop break. Let me all right. Okay, so console read key. Yeah, actually, I don't want to do this because I find it a little confusing. So I'm just going to move this somewhere here. There you go. Okay. And what is the example that I can do? I'm going to find for I is less than 50 and I plus plus nope. Console right line I times I. So I'm going to run that. Okay. All right. So yes. Okay, so let me do an example about this. As I discussed before, iteration has a lot of applications. It's not just about repeating always the same code to have some action on the program, but we can actually use repetition to, for example, search for a particular value or search for a particular condition by just sampling that condition over many different values and seeing which one is the first one that we like, right? So for example, I have this very simple for loop. It's a for loop that iterates 50 times, and it prints out the value of the number that we're using to iterate squared. So the number multiplied by itself. And if you can see that, this basically constitutes the first 50 squared numbers, the list of the first 50 square numbers. So 1, 4, 9, 16, 25, like numbers that come from a pure square form. All right. Now, let's say that for some reason, okay, I was doing some numerical calculations and I needed to find the first square number that is over a particular threshold. So for example, let's say that that threshold is going to be 500, all right? So I know that in this case, I could look it up here, and I know that the first value that is a perfect square number and that is over 500 is the value of 529, okay? So how could I use a for loop to start sampling all these numbers and figure out which one is the first one that satisfies that condition? So let's see a way that we could do that. So let's say that, for example, I'm going to start being more programmatic about these things. Let's say that we're going to define a variable called the threshold, and that's going to be 500, okay? And then here, what I want to do is I'm going to, instead of printing these numbers here, I'm going to check if the value of I times I is equal or is greater or equal than the value of threshold, the value of that variable that I have set to, for example, 500. And if it's true, then I will want to do something. Like, for example, print that one value to the console. All right? So what you can see is that I have modified this for loop, and now what is going to happen, because I have a conditional statement inside of the for loop, this line of code is only going to execute when this is true. So if the value squared is greater than this threshold, so greater than 500, then I will print that to the console. All right? And you can see that indeed, I only start printing after the very first number that is greater than 500. Okay? However, one thing that I may want to do is that I may only want to print the very first one. I may not want to print the whole sequence, right? Something that I should do is that whenever this condition triggers, I would like to print this, but then I would like my for loop to stop, okay? The way I can do that is with a special keyword that is called break. Whenever I use break inside of any structure that is iterating over a lot of things, whenever I call break, what break will do is it will stop that structure from executing, no matter the state of the check, no matter the state of the variables, anything. So what that means is that if at any point I square is greater or equal than the threshold value that I have set, I will print this to the console, and then I will break the for loop, hence not checking any other values afterwards. All right? So, and here you go. You can see that now my for loop is executing all the way until it hits that first value, and then it prints that message to the console. All right? And just to make things a bit cleaner, imagine that I was using this for loop to find which one is that value that that is over 500, which one is that square value, because I wanted to use that somewhere else in my program, because this was part of a more complex algorithm where I was searching for a particular value and then I needed to use that value. For me, it would probably not be enough to just print it out on the console. So what I would like to do is I would like to find a way to keep that value in memory forever, right? So that I can reuse it in my program. So what I can do is I can declare a couple variables before my for loop and say, for example, int first square value, all right? And I don't even need to initialize it to any particular value. And I can also initialize another variable called first value. So what is the actual first value that gives me that first square that is over 500? And then when this happens, instead of printing to the console, what I can do is I can say, well, the first value that I found whose square value is over 500 is the value of I. All right? And the first square value is that value. So I times I. Actually, this and this is a little redundant because by just keeping the first value, I know that the square of that value is already, so I don't really need to keep both, but I'm just going to do it for the sake of clarity. All right? And so what I do is whenever I find this threshold value, I keep it in memory as first value and first square, and then anywhere else during the life of my program, I can reuse those values so that I can reuse them for whatever purpose, for whatever algorithm. So for example, I can now here write a console line and I can write a nice interpolated string message like the first square value over the first square number over threshold is first square. And if I execute this program, oh, I have an error. So what happened? Use of unassigned first. Okay, so it looks like the compiler is not letting me use first square because it's unassigned. So what I'm going to do is I'm just going to initialize it to a dummy variable. And you can see now that I get the message, the first square number over 500 is 529. That number that I just found by running the for loop. All right. So long story short, break is very useful when you want to stop the execution of a for loop or a while loop or any other loop that you can think of. And using variables to store information that you have found through using for loops is also a really common technique. Okay. So yeah, that was it for this one. See you in the next video. Alrighty. Okay, so now let's go back to sequences of for loops. What were we going to do here? All right, we were going to do numerical sequences, and we were going to do Ascii Art as well. I see people are very excited about Ascii Art, so we can take a look at that. So, how am I going to start this video? Examples of numerical series. All right. Hi, my name is Jose Luis, and welcome to another video where this is going to be an example video where I'm going to be doing a lot of numerical sequences using repetition, using for loops, and using conditional statements sometimes. And it's part of a general playlist of learning computer programming using the C# programming language. Okay, so if you're here, you either came from watching all those videos on the playlist, or maybe YouTube or some algorithm just landed you here. But just so you know, this is a continuation, it's part of a whole curriculum where I'm trying to explain computer programming from scratch using C#, and you just got to the video where we just learn how to do iteration, and I'm just gonna indulge in doing like a bunch of numerical series to practice for loops, because I believe it's something that it needs a little bit of muscle before continuing to learn more about computer programming. So I have a list of numerical series that I want to do together with you, and the first one, we're going to start by the beginning, which is usually a good place to start. I'm going to just print out the first 10 digits from 0 to 9. Okay, so what is going to be the first 10 digits? That's going to be, I'm going to start a for loop where I'm going to start with the first number. So I'm going to declare an integer I, for example, which I'm going to initialize to 0 because I want to start from 0 and then go all the way to 9. Then if I want to print the first 10 numbers, then I will have to be less than 10 for this for loop to keep iterating. And then I'm going to increase this value in units of 1. And therefore, as I do that, I'm going to say console write line, and then I'm going to print the value of I. All right. If I run this code, you can see that, yes, indeed, I am printing right now the first 10 digits of so this is like basically the most canonical for loop that you can think of. And instead of adding comments, I'm actually just going to do this, okay? And then I'm going to just add an empty line here so that as we start drawing sequences, things start to look a bit more orderly, okay? All right, so I have that. So how about we try the first 10 negative numbers, all right? How does that look like? Well, first 10 negative digits. In order to do that, I'm going to have to rewrite my for loop. And then what I will want to do is, the list is probably going to look like 0, -1, -2, -3, -4, right? Or it could also look like -9, -8, but I think it makes more sense to do it in descending order. So because I want to start with 0, this is going to be very similar. I'm going to say int I equals 0. I, in this case, because it's going to be descending, what I want to do is, as it's going to be 0, -1, -2, I want to keep going as long as that number is greater than -10. All right? So that's going to be I is greater than -10. And then the list is going to be decreasing. So every time I'm going to take the value of I and I'm going to decrease it by 1 unit. So that's going to be I minus minus. And then as I do this, I'm going to print this to the console, and you can see that here I can see my first 10 negative numbers. All right, are we good so far? Okay, I'm going to substitute digits by numbers. I just find it a bit more clean. And also, I want to remind you of something. We haven't really seen this yet in this video series that we're doing, but I can declare these two variables with the same name, with the name I, because since I am declaring them inside of the for loop, the scope of this variable, so the lifetime, the expectancy, the life expectancy of this variable is just within this block, the block of the for loop. And what happens is that after the for loop finishes, that variable I stops existing. So because it was in the scope of this block. All right, I will explain more about scopes further down. But what that means is that since at this point in the life of the program, at this point, I doesn't exist anymore, that's why I can declare again another variable called I within this second for loop. And I will be able to do that anytime with any other of the for loops. All right, so just a quick clarification. Now, I'm going to now create another list, and this is going to be the first 10 square numbers. And what is a square number? A square number is a number that comes from multiplying an integer by itself. Or basically, it's the sequence of the first 10 digits whose square root is a perfect integer number. So those are going to be 0, 1, 4, 9, 25, 36, 49, and I'm getting a little lost right now, but you get my point, all right? So what am I going to do? I could say int I equals 0, right? And then I could say, well, but what am I using I for? Is it actually I? Is that going to be the value of the squares? So think about this. You don't really, when you declare the variable of I for a for loop, you don't really need to use that I as the actual value that you're hoping to achieve. You can use multiples of that value. You can use you can use like combinations of that value, etc. And since what I want to do is to find the first 10 square numbers, what I can do is I can generate the first 10 simple numbers and then square each one of those, and that's what I can output to the console. So what I'm going to do is I'm going to create a for loop that goes over this first simple 10 digits. So I is equal to 0, I is less than 10, and I plus plus, just like the very first sequence here. But then what I'm going to print is not going to be I, it's going to be I times itself. That's as simple as that. So I'm going to execute this, and you're going to see that I'm getting here the first 10 square numbers. Again, my point with this being, if you are generating sequences of numbers, you don't really always need to generate that exact sequence by manipulating the parameters of the for loop. You can generate that sequence by creating a series of numbers with for loop and then finding a way of using combinations of that number or permutations of that number with some other number to generate that list that you're looking at, that you're looking for. All right? All good so far? Okay, so what do I have? Now, I have on my list, for example, that we can say, let's try the first 10 even numbers. All right? How would that work? So the first 10 even numbers are numbers that are multiples of 2. So that's going to be 0, 2, 4, 6, 8, whatever. So there's two ways. There are multiple ways that I can go about that. So for example, one way would be I equals 0. I is less than, for example, 20, right? And then I increments in units of 2. Okay? So I am just creating the first 10 even numbers right away by manipulating the parameters of the for loop. So this gives me the first 10 even numbers. So it's from 0 to 18. Okay? So that could be a way to go. Now, but there are multiple ways of doing this. I'm actually going to comment this out, and I'm going to say, well, I can also just generate the first simple 10 numbers. So I is less than 10 and I plus plus. And then what I can print to the console is that number multiplied by 2, right? Just like I did before. So I can just do this, and the first 10 even numbers, I also get this result. All right? How does this sound? Or maybe for this particular case, it's kind of an overkill, but what I could do is, well, if I'm not sure, if it was a bit more complicated, then perhaps what I'm going to do right now makes a bit more sense. But you could also say, this is a very complicated operation. I don't really know what even numbers are. So I'm just going to sample, like, I don't know, 1,000 numbers. I'm going to find the first 10 that are even, which I'm going to do with using some kind of rule. And then once I'm done with those numbers, then I'm going to stop calculating this. So something that you can do is, for example, you can say, I'm going to sample the first 100 numbers, all of them, okay? And I'm going to say, and so from I starts at 0, I is less than 100, and at increments of 1 unit. And then what I'm going to do is I'm going to check if that number is even. So I'm going to say if I is even, and wait for a second. How do we know that a number is even? Well, a very simple way of doing that is by using the Modulo Operator and you can go back on my list. I have a video only about the modulo operator, and we know that if we divide any integer number by 2, and if the integer remainder of that division is 0, then that number is going to be even. All right? So that's what the modulo operator does. So if I modulo 2, if the result of dividing I by 2, if the remainder part of that division is equal to 0, remember we use double equals when we compare things together. Simple equals is assignment. So if this number modulo 2 equals 0, that means that the number is even. So I'm going to print this to the console. All right? I'm going to do this. And then you can see that, oh, I printed but I didn't print the first 10 even numbers. I printed all the way to 100, so I printed way too many, right? So what can I do here? Well, maybe what I can do is I can say, I'm going to create a variable where I'm going to keep track of how many numbers I have found already. So say I'm going to name it found, and I'm going to initialize it to 0, okay? So now, every time I find a number that is odd, I'm going to print it to the console. Then I'm going to take the value of found, whatever that was, and I'm going to increase it by 1 unit. All right? And just so that we can see it very clearly on the console, I'm just going to print here a message that says something like, found already this many even numbers. Okay, I will remove this later on. Okay, so let me see how that works. You can see after each one of these even numbers, I'm printing this message. Oh, I already found 39, 40, 41, whatever, blah, blah, blah. Okay, so what I can do now is I can say, I am keeping track with this variable outside of the for loop. I'm keeping track of how many numbers I have inside of how many numbers I have found that are even already. Okay, so what I'm going to do now then is I'm going to say, if the number of variables that I have found is greater or equal to the value of 10, then I don't want to keep checking anymore. I want to stop. So something that I can do is I can just say, just break, just stop the for loop, stop executing, stop everything. All right? And let's see if this works. So if I do this, you can see that indeed I get the first 10 even numbers, even though this for loop has probably run 20 times before it was called to break, because I just found more than 10 numbers. All right? For such a simple problem, even numbers, probably this situation is an overkill. All right? We can be a bit more smarter with simple for loops, but I think this situation, by having like a variable that we use to keep track of things that are happening inside of the for loops, we have one condition checking the even numbers. Inside of that we have another condition, whether if we have found too many numbers and we need to stop. I hope that this example starts giving you an idea of how, with these basic building blocks that we have learned so far, by combining them, we can start achieving like much more complexity and much more richness in our capacity to do to write algorithms. Okay, so this could be another way to go about this. All right. So which one am I going to choose? I don't know. I'm probably going to stick to this one. It feels a bit more elegant, a bit more clear. All right. Similarly, what about the first 10 odd numbers? Sorry, the first 10 odd numbers. How does that work? I wish I had students here so that I could ask them. So what do the first 10 odd numbers look like? Well, it's going to be something very similar to what I did before. It's going to be what I did before for even numbers is that I started at 0, it was less than 20, and I increased by 2 units. So it's probably going to be something very similar, but in this case, you can see that I cannot start with 0, because 0 is an even number. So what I need to do is I need to start with the first odd number. So that's going to be the number 1, And then I can see that by increasing in units of 2, I'm going to get 1, I'm going to get 3, I'm going to get 5, etc., etc. So I'm going to run this code, and then you can see that indeed I can start now with 1, 3, 5, 7, blah, 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 etc., etc. Okay? So that looks good. Another way I could do this is, again, simple as copying. I'm going to copy from the previous one here. I'm going to say the first 10 odd numbers. And in this case, what I can do is I can just sample the first 10 numbers, all right? 0, 1, 2, 3, 4. And then how can I use those numbers to generate the first 10 even numbers? Sorry, odd numbers. When I was using this technique for even numbers, what I said is I'm just going to take the value of 0, 1, 2, 3, 4 and multiply it by 2, right? But in this case, it's not going to work if I do that because it's going to give me 0, 2, 4, blah, blah, blah. What do you think you could add here or you could change so that this gave me, instead of 0, 2, 4, 6, 8, it gave me 1, 3, 5, 7. I'm going to give you 3 seconds. And some people in the chat are giving me the right answer right now. Thank you very much. Yes, so you can just take 0, 2, 4, 5, and if you add 1 unit to all those numbers, then you get all those even numbers. Sorry, all those odd numbers. So it's just as simple as taking 2 times the value of that number and adding the value of 1. So you can see here 1, 3, 5, 7, 9, 11, etc., etc., using this technique. And last but not least, what if I wanted to copy this technique here, the one that I said it was overcomplicated, right? The one that relied on using found and using integer, blah, blah, blah. Well, the code is the exact same code. It's just that I have to change just one number. And what do you think I would need to change from this algorithm in order to get the first 10 odd numbers? I'm going to give you another 3 seconds. Well, in this for loop, I'm checking the first 100 numbers, and I'm checking with this line of code, I'm checking if they're even. And if they are even, that's how I print them to the console, and then I add 1 unit to how many I have found, etc., etc. So what I need to do is I need to change this, and instead of checking if they're even, I need to check if they are odd. So what do I change here? Well, we said that the modulo operator means that if I divide the number by 2, what is the integer remainder of that operation? So in the case of 6 over 2, 2 fits inside of the number 6 3 times, and it fits perfectly, so the remainder is 0, and that's why 6 is an even number. But what about the number 7? The number 7, the number 2 fits inside of the number 7 also 3 times, but there is 1 unit left, and that's why 7 is an odd number. So what I can do is I can say, well, I can say if the remainder of that division, aka the modulo, is equal to 1. Or also, somebody's saying in the chat right now, if the remainder of that operation is not equal to 0, right? Both work in this case, then this number is going to be odd. So if I run this code now, you can see that the first 10 odd numbers, I can find them with this technique as well. All right. Which one of the methods do I like better or worse? Well, I still think this one is a bit of an overkill for such a simple scenario, but I thought it was very pedagogical, so I'm going to keep this, and we're also going to use this technique for more for loops down the road. So I kind of like this one for some reason. I don't know, I find it elegant, the first 10 numbers and then multiplying them by 2 and then adding 1. I kind of like this, so I'm just going to go for this one, but for no particular reason really. Okay. Some people, maybe pure computer scientists, would argue that this one takes like a few, it's a bit more optimized because it takes a few less multiplications to perform. I don't know about that, but at this level, I don't think those level of resources really matter at this point. Okay. Um, all right, I needed to breathe. What was that? Like 15 minutes doing for loops straight? Okay, sorry. Monique, you're really good at this, huh? I see you through the eye. I'm like, and I see you like giving me the right answers. I like that. Very badass. I'm gonna go. Yeah, I'm gonna go get some water. I'll be right back. Okay. Alrighty. Where is my microphone? How is this going? Is this too much? Intense? Too fast? Too little? What do you think? I think Monique is now starting to have some fun. Finally. Hey, Fernando, what's up, bro? Are you taking me diving or not? When is that happening? What did we say? Arrecife? No, Fernando de Caroña. What was it? What was the name of the islands? Those islands? Fernando de Garoña, Razaña. I forget. Uh, ah, doesn't matter. We're never going to travel again. Okay. Um, where was I? I was doing. I know, but you told me you were gonna take me diving to these islands in the north. No? Oh, okay. Well, then maybe I don't know. Okay, I'm fine. I can go to Rio too. I'll sacrifice for you, you know. All right. All right. Let's continue doing some more for loops. Wonderful. Let's continue and let's do some more for loops. So for example, something that is a very fun exercise is to plot on the console the multiplication table of a particular number. Okay. So for example, I'm going to copy paste here one of these modules, one of these blocks of code. Okay. And I'm going to say here the multiplication table of number what? What number? Actually, let's be a little more programmatic. Instead of hard coding that number, let's use a variable to define which number is going to be. So that's going to be, for example, multiplication value. And that's going to be, for example, let's say it's going to be number 7. So then here, when I print the message, I'm going to use string interpolation. So I'm going to add a dollar symbol here and open and close curly brackets, and this is going to be mult value. And so I'm going to plot here the multiplication table for number whatever. Okay. Now, what is the next thing that I'm going to do? When I write the multiplication table, what I want to do is I want to say the number times 0 equals whatever, the number times 1 equals whatever, the number times 2 equals whatever. So what I want to do is I want to be able to sample the first 10 values of the multiplication table and print a nice message to the console with that with that table. All right. So probably what I would want to do is I will want to have an iteration where I start with the number 0, or maybe I want to start with number 1. Maybe I want to start with number 1 because, I mean, typically every number multiplied by 0 is 0, and then this is going to be less or equal than number 10, or less than 11, whatever you want to make it. And then here, what I can do is I can print a nice interpolated message that says, for example, I'm going to print $1 here, and double quotes, and I'm going to say the value, so mult value times whatever we are, so the number I, so that's going to be 1, 2, 3, 4, whatever, has to be equal to those two numbers multiplied. And if you remember from the string interpolation video, what I can do is within the square brackets, I can actually, within the curly brackets, I can actually not just have one variable. I can have like a full expression, like a full statement there. So I can say, give me the multiplication value times I. And this is what we're going to plot on the screen. So if I run this code, you can see that all the way down here, I get 7 times 1 is 7, 7 times 2 is 14, 7 times 3, 21, blah, blah, blah. And again, why not? Let's just start with 0 and go all the way up to 10. I kind of like it better. It feels more rounded up, you know? And you know, my tiny OCD feels a bit happier with that. So 7 times 0 all the way to 7 times 10. And we can do that now for any single number that we can think of. So now this can be this crazy number, I don't know. But the code is so programmatic and so clean that that we get this. And actually, surprisingly, this is a very interesting example. This number is so large as an integer that very soon, when we start multiplying it with 3, it actually overflows the capacity of how large an integer number can be, and therefore it starts looping back into negative values, like here. So this is not a don't freak out about that. This is a problem with memory allocations and memory tables and how big numbers can be. So actually, if we want to make things work, something that we can do, I believe, is we can just change the type of this variable. Instead of being integer, we can make it long. And long is just an integer that has way more capacity than a normal integer. So if we do that, then I believe that we will get the actual multiplication table of this crazy number that I just typed. All right. So yeah, that was actually fun. All right. So, but I'm just going to bring it back to an integer just for the sake of, and then just make the number a little smaller so that we stay within boundaries. Okay? All right. So that's it for the multiplication table of a number. Now, another thing that we can do is we can just write a geometric series. And what does that mean? That means a series in which the numbers don't have a linear growth. They don't have the same step between them, but they grow exponentially. All right? And how can we do that? So for example, something that I can do is, instead of working with integers, as I described in the video, I can also use floats or doubles as numbers with decimal part that I can manipulate and that I can work with while iterating with my for loop. It's just that it's very typical to use integers because very, very often we want to relate the for loop to how many times we have looped over the for loop, but that doesn't necessarily have to be the case. All right. So for example, if I initialize a double value that is going to start at 1, for example, it's going to be v, and I'm going to start it at 1. okay? Then b has to be less than 100. And every time for each iteration, instead of adding 1 or subtracting 1, what I'm going to do is I'm going to multiply this value by 1.5 times, so that the number starts growing, but it starts growing increasingly large over time. So what I'm going to do is I'm going to multiply this by 1.5, and then I'm just going to simply print it to the console as is. If I do that, you can see that the number starts growing, 1, 1.5, 2.25, 3, blah, 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 and then it becomes larger, much faster than it used to here, all right? And the fact that these numbers like form this really beautiful pyramid is kind of coincidental, because of the 1.3, I think. If this was 1.68 or something like that, it would probably not be so beautiful. Yeah, it's a little messier here now. But we could make this much larger if we multiply it by 1.21, so like a very small number. You see, the series will be much larger because it takes more time for the number to grow. Okay? So let's say we just keep it at 1.5 as a geometric series. Okay? And similarly, we can write a very similar series where we say, let's say that this is going to be an ascending geometric series, and this is going to be an asymptotic geometric series. It's going to be asymptotic because I'm going to start with the value of 1. I'm going to request that this value is greater than 0, and then what I'm going to do is instead of making it grow, I'm going to make it shrink. So every time I'm going to multiply the value by half. So I'm going to do plus equals 0.5. Okay? And then I'm going to run this code. This code is a little weird for the reasons that you're going to see right now. If I do this and I print it, you can see that, ooh, what is happening here? That was a little strange. Let me scroll up a little bit. Ooh, so we have, what is this, about 200 values? So look at what's happening. The value starts at 1, becomes 0.5, 0.25, 0.125, blah, blah, blah. But the number starts getting very, very small. Like very, very small, like 0.000. And at some point, it gets so small that it switches to exponential notation. Exponential notation is basically, this is the mantissa, is basically the significant part of the number. And then this is how many zeros to the left we need to move the comma so that this number is actually a real number. So what this number means is that it's this number with this comma moved 5 digits to the left, or with 4 extra zeros in front of it. All right? And see what happens. This is 5 zeros, 6 zeros, 7 zeros, 8 zeros, and very soon, the more we start decreasing, we start getting like 155 zeros, 255 zeros, 324 zeros. So this number is literally 4.95 with 323 zeros in front of it. It's like a really, really small, like a tiny number, you know? What happens is that this sequence that I just created, basically it's ill-defined. It's ill-defined because it's asymptotic, because a number that I keep making it half and half and half and half and half is like the Achilles and the tortoise paradox. That number will never, ever, ever reach 0. And even more importantly, that number will never, ever, ever become less than 0. Because a number that I keep making half of will always, always have some kind of value over 0. The problem is that the series actually ends up finishing. It ends up finishing because double numbers have a lot of precision, but they have a limit to that precision. And the precision cannot be any more than roughly what you just saw. A number with 320 plus zeros in front of it. So a number with 320 plus decimal parts. All right? And that's why when it reaches the limit, it basically just snaps to 0 which is not what it should be in a purely mathematical environment, but it just snaps to 0 due to the limited precision that computers inherently have. All right. So if I were to fix this so that it wasn't an asymptotic geometric series, but it actually ended at some point, I could just specify here some very small number. So long as this is greater than 0.01, then keep going down. Or, right? And then the number just becomes smaller, smaller, smaller. All right? Or maybe I can add a couple zeros here, and to get a few more values right there, you see? But theoretically, again, this series could never reach the value of 0, just by making every number half of the previous one. It just doesn't work. All right? Oof. What are we doing next? Okay, so we've done a lot of for loops with integers. We've done a couple of for loops with double values so that you can see that we don't always have to increase by 1 or decrease by 1. But we can also use for loops not to print stuff on the screen. We can use for loops to generate sequences of other things. So for example, let's say that we wanted to use a for loop. Let's say that we wanted to generate an alphabet in a programmatic way. I wanted to generate a sequence of all the letters in the alphabet, one after the other. How could I go about that? Yeah, I could just say string alphabet is going to be equal to A, B, C, D, E, F, G, blah, 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 but like I'm already tired. I'm already tired of doing this. And there's got to be a better way. There's got to be like a programmatic way of doing this, right? And this is also prone to errors. Maybe I'm a human and I forget a letter, or maybe I'm using an alphabet that I don't control, or that is not my natural one. So this is probably not a good way to go. So the way to go about this is that I can use a for loop to iterate over all the letters and then add that letter to the alphabet that we are creating. And I'm going to stop because the sun started to hit me. So I need to close the window. Give me a second here. All right, where was I? Yes, I was doing alphabet. Okay, so alphabet. And my microphone is working, yes. So how are we going to do this? The way we're going to do this is we're going to first initialize a string variable. We're going to call this the alphabet, and this is going to start empty. All right? And then one at a time, with a for loop, what we're going to do is we're going to generate a new letter, and then we're going to generate a new letter, and then we're going to stitch that letter to the string that we already have. Okay, so we're going to concatenate that letter to that string that we are using as the alphabet. So how is that going to work? How many letters are in the alphabet? 24? I forget. The Spanish alphabet has like a few more letters, I think. Anyway, so let's say that I start let me say this. I start a for loop that starts with 0, I is going to be less than 24, and I is going to grow in increments of 1. Okay? And then what I need to do is on every one of these cycles to the alphabet string, I need to add a new letter. But wait, how do I generate those letters? This doesn't work, because if I add I, and then I print here to the console, if I print alphabet and I print a white line, then what I'm going to get is not that, but it's basically like all the numbers one after the other. So that doesn't work. So how can I use these 24 numbers to fetch a letter? Huh? So we're going to use a very simple trick. Let me fire up a browser, and what I'm going to do is I'm going to pull up the Ascii table. So I don't know if you're familiar with this. I spoke about this on my Harvard computational design lectures, etc. But basically, a very early representation of a very early code to represent letters through numbers was the Ascii table. And this Ascii table, in this Ascii table, you can see that basically every character, here denoted in red, every character has representations in octal, in hex, and in decimal numbers. Which means that, for example, in uppercase A, in decimal numbers, is the number 65. And lowercase a, in decimal notation, is the number 97. So if, let's say that I want to do an alphabet with uppercase letters, I know that A is going to be the number 65. So what I can do is I can say, I can take the number 65 and convert it to a letter that then I can switch into that I can concatenate into the string. So what I can do is I can say, let me take the number 65, which is the letter uppercase A, and then use casting. We already recorded a video where we speak about conversions between different types, and it just so happens that when you convert simple numerical integers to characters, by default by default it uses ASCII representation. Well, it's not exactly like that, but it uses UTF-16, but the first 255 numbers of UTF-16 correspond to the Ascii table. It's a long story, but bottom line, 65 corresponds to the uppercase letter A, and 97 corresponds to lowercase a. So if I do this, you can see that the number 65 gets converted to the character A 24 times, all right? But this is not the alphabet. This is just A repeated 24 times, right? So what I need to do is I need to use these numbers here, and so every loop, what I'm going to do is I would like to concatenate into the string. I would like to concatenate number 65 plus 0 plus 1 plus 2 plus 3, so that I do A, B, C, D, E, F, G, blah, 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 blah. And A, B, C, D, blah, 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 and it looks like I'm missing a letter, so probably it's 25 here. All right, oh no, still it's 26 letters, apparently. And now we got it, all right? A, B, C, D, F, G, blah, 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 all the way down to C. If I wanted to make this lowercase, I could just switch this to the number 97, and then I would have the letters lowercase, okay? And then I'm going to pimp this up a little bit, the alphabet, okay? And just for the sake of flavor, something that I could do is I can print how the series alphabet keeps growing over time. So something that I can do is I can just, I'm going to create an interpolated here, interpolated string, where I'm going to print the value of I, and then semicolon, a colon, and then the value of alphabet. And this way, we can see how for the numbers 0, 1, 2, 3, the alphabet string keeps growing in a pyramid kind of way. You see? 0, 1, 2, 3, how the letters keep growing all the way until we get the full alphabet. How does this sound? Is this cool? Are we learning anything today? Okay, so this idea, the idea of using a for loop, in combination with a variable that I have defined outside of the for loop, and we will see very soon why that is important due to the rules of variable scoping. We will, we're using a variable that we have declared outside, and then inside of the for loop, start working and adding and modifying that variable is a really, really common technique. It's so common that it's very useful for a lot of things. So for example, let's say that I wanted to calculate the addition of the first 10 numbers, aka 0, what is the result of adding 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus blah, blah, blah. What is the result of that? Okay? So let's say that I'm going to create here the addition of the first 10 numbers. So I can create a for loop here and say I'm going to iterate starting at 0, and it's going to be less than 10, and it's going to be I++, and then I'm going to write here that value. Okay? But because what I want is, I want one number, and I want to add all these values that I'm generating, 0, 1, 2, 3, to that number, and then print the result, then this is not exactly what I want. What I would like to do is I would like to create a variable called, for example, mass addition, and this, I'm going to start it at 0, and then for every iteration of the for loop, what I'm going to do is I'm going to say mass addition should be equal to whatever the value was of mass addition was before, plus this new index, this new value that I just generated. Okay? Or if we like shortcuts, then this that I just wrote is exactly the same as writing plus equals. All right? So mass addition, add the value of I. And then here afterwards, I can just say, I can just print mass addition and the result. So what that gives me is that the addition of the first 10 numbers is the number 25. All right? Yeah, you're right. I'm getting the sunlight in, Maybe I should just stay back. There's not really much I can do. Because if I close, there's going to be very little light. Let me see. How is the light now? Am I dark? No, it's actually good. No? Okay. All right, it's fine. All right, cool. And then let's do the Fibonacci sequence, and then we wrap up this video and we move on to the next video where we're going to do some Ascii art. All right, the Ascii art is going to be super, super fun. Yes, so we were here, and then we're going to do the Fibonacci sequence. Okay. All right, so let's keep going. And then what about, this is going to be a good one. What about the Fibonacci sequence? Huh? Do we know what the Fibonacci sequence is? Who knows? The Fibonacci sequence is very simple. I'm just going to write it here. The Fibonacci sequence is 1, 1, 2, 3, 5, 8, and then it's 13, and then it's 21, and then it's 34. 34. Who knows where is this coming from? The Fibonacci sequence is a sequence where we start with 2 number ones, and then every number after that is the addition of the 2 previous numbers. So 2 is 1 plus 1, 3 is 2 plus 1, 5 is 3 plus 2, 8 is 5 plus 3, etc., etc. You get it, right? So what we need to do, let's say that we want to create, for example, we want to print out the first 10 or the first 12 Fibonacci sequence values, okay? The way we're going to do this is that just like we are using external variables outside of the for loop to, just like we're going to use external variables outside of the for loop to keep track of something that we're calculating, we can use that similar technique to also keep track of certain values that we need to keep in memory, all right? And so that we can, for our calculations, for our present calculation. What that means is that we're going to create a for loop where we're going to go over a bunch of numbers. We're going to look at the 2 previous ones that we generated. We're going to use those 2 to generate the new number in the sequence. We're going to print that to the console, and then once we have that, we're going to update those 2 last numbers to the new 2 last numbers that we have calculated. All right? So what does that look like? It looks like something like this. Let's say that I say previous number first is going to be equal to 1, and previous number 2 is going to be equal to also the number 1, because we have to start with those 2 values. All right, we're going to print them to the console. So I'm going to say, let's print this one, and then let's print previous 2. And then what we're going to do is now we're going to create a for loop where we're going to iterate 10 times. So I equals 0, I is less than 10, I plus plus. And then in this, in this side of this for loop, we're going to create a new variable, which is going to be the sum of both previous values. So previous 1 and previous 2. Okay? And we're going to print this to the console. We're going to print here sum. All right? Now, if I run this code, you can see that, yes, we get, oops, what have I done? We get 1, we get the sum of the 2 previous ones. So 1 and 1 is 2. But then after that, we keep getting the value of 2, right? So this is not really working. And it's not working because every for loop, every iteration of the for loop, we're calculating the sum of previous 1 and previous 2, so the 2 previous values. But there is nowhere in the code where we're changing previous 1 and previous 2. Through the whole life of the for loop, previous 1 and previous 2 maintain those values of 1 and 1. So that's why we keep constantly printing to the console 2, 2, 2, 2, 2. All right? So what we need to do is, after we calculate it and we print it, what we need to do is we need to update the values of the 2 previous values that we will use in the next iteration of the for loop. All right? What does that mean? What it means is, whatever value I had here in previous 2, I probably need to pass it on to previous 1, and then previous 1 is forgotten. And then the value of sum, that value of the calculation, should become the value of previous 2. So that in the next cycle, this value had moved 1 unit, and this value is the sum of the previous cycle that we just calculated, right? So how are we going to do this? Well, it's going to be pretty easy. So previous 1, whatever it was before, I don't care anymore, that's going to disappear, because now it needs to be the value of previous 2. So previous 2 moves on one position back into the line. And then previous 2 is now going to be equal to the value of sum, so that for the next iteration, I have the 2 latest numbers that I've calculated in this series. All right? So I think at this point, we are ready to give it a try, and it should probably work. Is that correct? 1, 2, 3, 5, 8, 13, 21, 34. I think it works. The Fibonacci sequence. All right. How cool is that? I'm so nerdy sometimes. I love it. All right. And I'm going to try to print out the first 10 prime numbers. I've never done it. So I'm going to give it a try. And if it doesn't work, or if I think it's too complicated, then I will not add it to the video. But if I find a simple way of doing it, I think I'll just add it. So bear with me. Are you ready? Let's give it a try. So we're going to do nested for loops, because what we're going to do is, what are we going to do? We're going to have a for loop where we're going to iterate over the first 100 numbers, okay, for example. And we need to find 10 last prime is going to be equal to number 2. Okay? And then this should start with number 3. Okay, so because the first prime is number 2. The first prime is number 2. The second, and then after that, every number after that, if I divide it by all the numbers below that one and up to 2, wait. I'm not sure what I'm doing. I'm not sure what I'm doing here. So let's say, let's forget about this. So now here, let's say, I start with a value of 3. Well, yes, it's been 2 hours. Maybe I am not. Maybe is this going to be good? I mean, I don't know if it's going to be good or not, but I'm definitely a little thick right now. Let's not care about number. So I create a for loop here, which is going to be j, and it's going to start at 1 I minus 1, and then it's going to be all it has to be greater than 1, and j has to be and j minus minus, and then if so I could have a flag here, bool prime equals true. If I modulo j equals 0, then prime equals false, and then I can break. And then if prime, then console write line I. Does this work? Oh God, it works. Okay. What if I start here with number 2? It doesn't work like that. Oh yeah, it does work. Oh, okay, so that was easier than I thought. So that's going to be prime numbers. All right, so I'm just going to copy it here somewhere. Okay. Okay. All right, so let's do this. Woohoo! How are you doing, Monique? Are you holding on? Is this fun finally? Okay, so, all right. Okay, and finally, in case you hadn't had enough yet from this video, we're going to do perhaps like the most advanced sequence of this exercise, which is going to be, we're going to calculate within the first 100 numbers. Okay, we're going to calculate which ones of those are prime numbers. Okay, and in order to do that, we have to remember that a prime number is that which which has, I actually don't know how to say this in English properly, is any number that when divided by any of its numbers below, no, that's not the right, okay, we're starting over again, okay? So what is a prime number? What is the definition of a prime number? Prime number, it cannot be a product of two smaller natural numbers. Duh. All right. Okay, it's not. It cannot be, or it cannot be divisible by any other number. That's what I want to say. Okay. All right. Let's start over again. Okay, and now, last but not least, we're going to do perhaps, well, not perhaps, clearly what I think is the most advanced or the most hacky series of these videos yet, in case you hadn't had enough, which is going to be, we're going to calculate for the first 100 values, 100 numbers, we're going to calculate which ones of those are prime numbers, okay? And for that, we need to remember what a prime number is. A prime number is an integer, is a natural number that cannot be divided wholly by any other number below it. Or in another way, it cannot be the product of any other two numbers and of any other integer numbers. All right? Which means that basically, if you have a prime number, you cannot divide that number by any other natural number below it and get a number without decimal part. All right? So those are the ways that we can think of prime numbers. So what we'll have to do in order to figure this out is create a for loop, go over the first 100 numbers, and then figure out if for that number, if dividing it by all the numbers that are below it, if any of those divisions gives me an integer division, gives me a division that has no remainder, that has no decimal part. Okay? And if that happens, then and if there is a number that gives me no decimal part, then that number is not a prime. But if I can't find any, then that is a good number. It's a prime number. All right? So how am I going to do that? Well, first of all, I'm going to write here a header. So prime numbers. All right? And what I'm going to do is I'm going to create a for loop that is going to go over the first 100 numbers. Or the first 10 numbers, whatever. Let's do 100. I think it's more fun. But in this particular case, I'm going to start by the number 2, because we cannot really start by the number 1. The number 1 is prime, but it's obviously, there's no number under it, so you cannot really divide it by 0. That's actually not possible. It's an indetermination, right? So what I'm going to do is I'm going to start by I equals 2. I has to be less than 100 and I plus plus. All right. As I do that, what I'm going to do here is that now for each one of these numbers, 2, 3, 4, 5, 6, whatever, what I need to do is I need to take that number and divide it by all the numbers below it. And again, all the numbers below it except for the number 0 and the number 1, because every number is divisible by number 1. Okay? So what can I do for that? Well, in this case, we're actually going to have to apply the technique of nested loops. So for here, for all the 100 numbers, for each one of them, I'm going to have to create another for loop where I'm going to try to divide that number by all the numbers below it. So this is going to be a bit trickier. So let me show you how this works. So here I'm going to create a for loop. I'm going to declare another variable. This one is going to be called j, all right? And what I'm going to do is that j is going to be the number that I'm going to be dividing I by. So if I is 6, for example, I want to start dividing j by, by 5, 4, 3, 2, etc. Or I want to start by 2, 3, 4, whatever, in whichever order you want, okay? So j is going to be the number that I'm going to use to start dividing. So let me say that this is going to start at 2, all right? And I'm going to start dividing all the way up. So I'm going to say, if j is, so if I is the number 6, for example, then I need to divide 6 by numbers that go from 2 to 5, all right? Which that means that j is going to have always to be equal, sorry, it's going to have to be less than the value of I, all right? So the numbers that I'm going to use as divisors are going to start at 2 and are going to go all the way to the value of I minus 1, okay? And then here I'm going to say j is going to grow in units of 1, okay? Now, so what I'm going to try to check here is dividing I over j and seeing if the remainder of that operation is a whole number, is a number with no decimal part, all right? So what I could do is I could actually try to do the real division. So I could like cast I, j to doubles, make that division and see if the decimal part is perfectly 0. But that is a little complicated, and since these two numbers are already integers, there's actually a better way of doing that. The better way of doing that is that I can say if I modulo j equals 0, then that means that the division of a over j doesn't have any remainder, so it's a perfect division of two natural numbers, which means that that number is not going to be prime. Okay? So if that number is not going to be prime, then what I can do is I can already break from my calculations, because for that number I have already figured out that it's just not possible, that it's not a prime number. Okay? So we are getting close. So let's see if this works, or let's see if it gives me like an infinite, some kind of, no, it looks like it's working well. All right, so that is working well. Now, now what I need to do is, if no number was found that was equal to 0, that the modulo was equal to 0, then what I need to do is I need to print that to the console. So something that I can do, a technique that is very popular, is to use what's called a flag. All right. A flag is nothing, it's like a nickname for a technique that involves creating a Boolean variable that I can use to keep in memory to remind myself if the number that I'm currently calculating is a prime value. So for each one of the I values that I'm checking, I'm going to create a new Boolean variable. So that I'm going to do here inside, just right above the second for loop. I'm going to create a variable called isPrime, and I'm going to initialize this to the value of true. So until proven guilty, I'm going to think that all numbers are prime. However, if I find that at some point dividing I over j gives me no integer remainder, so it's a perfect division, then this number is actually proven guilty. And then what I can do is I can change that variable is prime, I can make it false. All right? So again, I'm creating a variable to remind myself if I is prime, I initialize it to true, all right? And then I'm going to check all the other values below I if they do have a perfect division. And if there is a perfect division, then the number is not going to be prime. I don't need to keep checking any more of those values, so that's why I break from my for loop. And then after that, after I have created the value and I have checked against those divisions, at this point in the code, I should have a value for isPrime, which is either true or false, depending on those calculations. If at this point the value of isPrime is still true, it's because no other number here was found that gave me a perfect division. So what I can say is if isPrime equals true, if the value of isPrime is still true, then I can safely say, let's print the value of I to the console, because I know that this is going to be prime. And let's see if this works. Yoo-hoo! It looks like it may have worked. So let's take a quick 2, 3, 5, 7, 11, 13, 19. Whoa! These numbers look prime to me. I don't know what you think, but they look pretty prime to me. All right. There's no number that ends in 2 or 4 or, there's clearly a number divisible by 2, by 5. Those are very easy to spot. So probably it's working. All right. So and you can see how we have made use of nested loops for the sake of performing a computation that is purely numerical, which I find is pretty nice and pretty elegant, I think. These things are a bit difficult to explain verbally. I should have probably used some diagrams, but whatever. I guess that's what I just did. Okay, so this is going to be the end of this exercise where we have reviewed for loops, and I have explained a bunch of other examples of how to use for loops, perhaps in non-standard ways. But again, trust me on this one, probably like 50%, 60% of the for loops that you're going to write are going to be as simple as that, as like int I equals 0 is less than whatever number and I++. That's like literally the bread and butter of writing for loops, okay? However, I wanted to expose you to some other examples and some other techniques, and hopefully like open up your brain a little bit about how we can combine everything that we have learned so far to make more complicated, more interesting algorithms. Like for example, the prime number one, which I thought was a really interesting example. Okay, so thank you very much for being here. If you like what you just saw, please subscribe, hit the notification button, and keep watching this series where I'm trying to break down the secrets of how to write code using, in this case, C#. Okay, see you in the next video. Woohoo! That was a lot. Oy. That was a lot. Oh. And I'm very tired. How are you? How's everyone feeling? Should we do Ascii Art? Or should we wait? Or should we do that some other day? Oof. I feel a little tired, honestly. Um, yes, I don't think I can do Ascii Art today. Can we do Ascii Art? No, we will definitely do Ascii Art next time. I wonder if we can do it now. Maybe, how difficult can it be? Um, it's just nested loops and conditionals, really. Um, okay, let me think about it. Let me think about it. What could we do for? So we could do. What we could do? Could we do? I don't even know. We could do a rectangle. We could do a rectangle with a hollow part inside. We could do a pyramid. We could do a diamond. We could do cellular automata, Andres, and that can be done with Ascii Art as well. Whoa, that would be really cool. Oh, that is pretty cool. We can also do like linear. We can do linear Ascii art based on Stephen Wolfram's cellular automata. That's a pretty neat exercise. But for that we need a race. For that we're going to need a race. So I don't think we're there yet. But that's actually a really nice exercise. Andres, that's a really good idea. I loved it. So let me write this down here somewhere. Wolfram's cellular automaton example in C#. Well, so how can we turn a list of integers from 0 to 25? How could we convert them into binary sequences of zeros and ones? Well, that's actually. Wait, am I on the screen right now? That's actually a pretty interesting. Let's say I'm going to create a string, which is going to be the binary integer, okay? And that's going to be this. And then the number that you want to convert into binary is going to be yeah, we can do that some other time, Andres. I'm a little brain dead right now, but it's actually pretty easy. Okay, so okay, you know what? That's a pretty good challenge. Do we want to make a challenge out of that? Using for loops, how can I turn the one number that goes from 0 to 256, or sorry, 255, how can I turn that into a string that is zeros and ones? Okay? That's actually a pretty interesting, and actually, it's actually quite simple now that I'm thinking about it. Well, it's not quite simple, but it's pretty neat. That would have been a great for loop to do here, now that I'm thinking about it as well. Okay, so we're going to do that as a challenge, definitely. Taken how to convert with for loops, how to convert an integer from 0 to 255, how to convert it to a string that is zeros and ones, and its binary representation. I like that. Yeah, yes, I am sorry. I just don't think I can do Ascii Art right now. I'm a little brain dead. And I don't think it's going to happen. Sorry. We'll do that. We'll do that next time I record. Maybe I get some time to do another stream sooner during the week, like Monday afternoon or something like that. Yeah, so let's put it. So that's going to be the coding challenge for today. The coding challenge is we're going to help Andres, all right, and we're going to write a small algorithm that, given an integer number from 0 to 255, it gives us a string that has 8 zeros and ones representing its binary representation. How does that sound, Andres? Do we like that as a challenge? Who's accepting the challenge? Can you raise your finger like this? Who's going to take the challenge? All right. And that can be solved pretty easily using using a for loop. Actually, using one for loop, I think. We don't even have to do nested for loops for this one. Good. Okay, hints, so tips. What I would do is I would definitely use the modulo operator. All right, that's definitely going to be your best friend. And I also think I'm under the impression that using the power, so the math.power, the math.power arithmetic function will probably be quite helpful. All right. So I'm going to, yeah, I'm actually, wait, can I do this right now here? That's kind of disrespectful if I do it without showing you. All right, that's going to be the challenge for next time we meet, or next week, or whatever. Okay, so that's it. I will write that challenge on the Discord, and then we can talk about it, and we can share snippets of code. Okay. And that's gonna be it. Do you have any other questions, suggestions, talk, a little bit of Q&A and social before I move on? I still have a lot of work to do for next week, preparing my classes. I actually need to record a lot of videos for those classes. Okay, so the chat looks a little sleepy. It's been 2.5 hours. I mean, yes, Fernando, of course you can ask a question. Please go ahead. But yeah, it's been 2.5 hours. I'm super brain dead, and I will understand if you're totally brain dead as well. Fernando, whenever you're ready. Ooh. In your last prime number, you set the Boolean true inside your first for loop. Yes, I did. So yeah. The result of this Boolean is not particular of this if. I'm not sure if I understand that. I set a Boolean variable here that is called prime, and then the result of this Boolean is not particular if this if. I'm not sure what you mean by that, sorry. I'm really brain dead right now. If you can elaborate better. Ah. Whew. You still there, Fernando? Can you hear me? Are you typing? Is prime only changes inside if? Yes. So exactly. So this it starts at true. So every time this this prime, so this prime variable here, it gets created a new for every single of these for loops here. So every single of this I create a new variable called is prime. And I haven't really explained yet the idea of variable scoping, why I'm declaring this here as opposed to declaring it here. All right. So I will explain that in a future video very soon. But what I want is to create this variable here and start it to true. So when I'm looping and making all these other divisions, unless I find a perfect division so that the modulo is 0, unless I find this, prime doesn't change. It sticks to true. Only if I find this perfect division, is prime changes to false. Only at that one iteration. And then I also stop checking for any more divisions using the break clause. Now here, after I execute the for loop, what I do is I check the value of prime. If I found no perfect division with this for loop, then prime should still be true. If I did find any perfect division here in the if, then prime will have changed to false. So at this point, if prime is still true, there was no perfect division, so it is a prime number. But if it is false, then it has changed, and then it's not a prime. That's just it. The reasoning behind this variable is that I need a way of remembering after I run my whole for loop. I need a way of remembering if I have found a prime number or not. If I just break here, then yeah, I stop executing. But if I don't find the perfect division, then I have no way of knowing if there was a prime or not. So it's just one simple variable to remind myself of what kind of result have I found. All right. Okay, so with that, I think I'm going to call it a day, and I'm going to call it a weekend as well. So thank you very much for sticking around. It was a pleasure. I'm very thankful that you stuck for 5 hours with me today. That was quite a lot. But we'll chop these videos, we'll put them online, and thank you very much for being around, and stay tuned for the next streaming, which I'm not sure when it will be. Okay, but I will announce it everywhere. All right. Thank you very much. Have a good weekend. Stay healthy. Stay fun.